Hi, everyone. Thank you for joining me today. My name is Steve Lang, and I'm coming to you live from the Canadian Space Resource Centre, which is a part of the TDSB. I am located in a high school called Mark Garneau Collegiate. And today we are going to look at that latest rover that landed on Mars in February called Perseverance. Now, normally I do these talks one-on-one with the class, and we have the opportunity to interact. Students can ask me questions. I can ask them questions. There's a little bit of a dialogue. And unfortunately, with the numbers, we've decided to use YouTube. We can't do the other format. So the live question part isn't going to happen. But we have had a number of questions from students. I have put them throughout the presentation to answer them, and I will let you know when those questions pop up. So before we begin, as always, we'd like to start with the land acknowledgement. Let me just flip over to that. We begin each day by acknowledging the land upon which we live and work. Please stand as you are able for the land acknowledgement, followed by O Canada. We acknowledge we are hosted on the lands of the Mississaugas of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. Okay, again, thank you for joining me today. And our topic is the Perseverance rover. So in case you weren't paying attention to the news, it was certainly everywhere. This happened on February 18th, 2021. So that, of course, was an animation. I will show you some live footage a bit later on. In talking to young people, a lot of them, they thought it was cool, but they weren't quite as impressed as maybe some of the older people who have been watching Mars exploration and robots to Mars for a very long time. But let me just put this in perspective. What NASA did on February 18th was land a rover the size of a small car on a planet 200 million kilometers away. That's pretty difficult to do. By the way, that rover weighs over 1,000 kilograms. So when we talk about the rover, there are two parts to it. There's the rover Perseverance, which I'll refer to as Percy, and tucked underneath is an experimental helicopter or drone, excuse me, called Ingenuity. Often with NASA, they do test vehicles first to see what the problems are, see if they can make things happen. And then, of course, later on, they'll come up with hopefully a bigger version if everything is successful. So students often ask, excuse me, why Mars? And I think there's a couple of answers for that. First of all, if you ever go out and look in the night sky, it's obvious. If Mars is up there, you'll see it. It's red. It draws your attention. It's distinctive. So much so that in 1610, Galileo, using the telescopes of the time, was drawn to it. He would look at it, sketch it out, and one of those sketches is on the right. There was a darker area. Remember, the telescopes weren't as clear as they were today, so their resolution wasn't that great. Now, he did call the dark areas mare, meaning seas or oceans, not really understanding what it was he was seeing. He just kind of looked at it and said, well, on Earth, we would have areas that were big like that probably were seas, so that's what they called it. Now, as NASA developed its rocket and other technologies, it started to explore further out into our solar system. And one of the first targets that we wanted to go and explore was Mars. The Mariner 4 mission in 1965 was the first one to actually get images sent back from Mars. And of course, our technology has gotten much, much better, but we always start somewhere. And I think one of the other reasons that we're drawn to Mars is we're trying to answer one of the questions of, is there life out there? Are we the only ones? And you look at the planets, well, Venus is very, very hostile. And Mars, well, although it's not the greatest, it's pretty hostile as well. At least we can get robots to survive there. So that is sort of a natural choice. So in the mid-1970s, one of the things that NASA decided to do was send 2 identical landers to go and see if they could answer this question: is there life on Mars? So they built 2 of them, Vikings 1 and 2, and they don't move around. So wherever they landed, that was it. They would be able to take some soil samples and check out to see if there was life there. So here's some images from those Viking landers. You can see the color. I love to tell students to look at the rocks. Look at how many rocks there are. And I will talk a little bit more about that later on as to why that is kind of a big factor. But the Viking landers had a robotic arm. It would scoop up the soil and put it into a little sort of laboratory and do some analysis. Now, they did discover some unexpected and chemical activity in the Martian soil, but there was really no clear evidence of living organisms, past or present. But the thing is, that's near the landing sites. They can't move anywhere else. So there could be life 100 meters away, and yet because they had a limited reach, that was all they could test. They wouldn't be able to find it. Now, if students are looking on the internet or in older books, magazines and things like that, you may have heard or seen an article about life on Mars. NASA in the 80s actually made an announcement after having discovered a meteorite that had landed on Earth in the Antarctic, I believe, and they dug it up and they studied it. They cracked it open. The marks you see, the little squiggles, were what they found inside. That was microscopic. They made this announcement, and then what happened was they said, okay, well, we think there was life on Mars in the past. They then hand over their data, and the other countries, the other scientists get to study it as well. And at that point, some of the scientists said, you know, you made a few big leaps in your judgment here. This is definitely not 100% proof of life. So then they sort of retracted the information. And of course, sometimes life is the basis for books, and this is no exception. Dan Brown, a famous author of the Da Vinci Code, actually wrote a book based on this whole idea that the meteorite with the evidence of life from Mars. So they realized that if they wanted to go back and explore some more, that the best thing to do is to have a rover that could move around so they could explore and look for life in multiple places. And as I said, what NASA tends to do is they create a small test vehicle to work out all the problems, see how things are, and then they would build a much larger version. So in the mid to late 90s, they built the Mars Pathfinder, which consisted of 2 parts, a base station and a little rover called Sojourner. By the way, the gentleman you saw in the image of the Viking landers, that was the NASA scientist or astronomer named Carl Sagan. The base station was named after him. He had passed away at that point. So here we see actual footage from that mission. You can see again the number of rocks. You can see the lander with its solar arrays, the base station. It has 2 ramps, which was a great thing because if you look carefully at the ramp on the left, it's not quite on the ground. Those white things are landing bags that they used, and the bags didn't fully deflate or pull inside, and so that ramp is kind of being held off the ground. Had that been the only ramp, then the little Sojourner robot probably wouldn't have been able to survive going off the edge. By the way, those ramps, part of them anyway, were built in Canada. So luckily we had this, if you look in the lower picture, that other ramp and the little Sojourner robot was able to go down and start to explore. Now, one of the things that we have to understand about exploration, and of course, this was the first time anyone was trying to control a robot from another planet. And of course, we're about 200 million kilometers away. So it's not that easy. And they don't go very fast. They don't go very far. The Sojourner robot did not really go far from the base station. It couldn't. It needed to be able to contact Earth that way. And one of the things is, if you look at the words that are written on there, it's showing you the distances and the directions that the Martian Sojourner would go in a period of time. So a day on Mars is not the same as a day on Earth. And it gets confusing when you're working on two different planets, living on one, working on the other. So they say, look, if we use the word day, is it an Earth day or a Mars day? They use the term Sol to indicate a Martian day. And if you look carefully, you'll see Sol 24, Sol 25. That was the distance Sojourner went in that one day. Really not very far. Now, the rover was supposed to last for 1 month. It lasted for 3 months. It was a great success at showing NASA how they could actually do this. And so they then built a larger version. In fact, they built 2 more robots called Spirit and Opportunity. These are now about the size of a kitchen table. Again, solar powered. The mast that you see there, the white part sticking up with the 2 lenses or cameras. By the way, those lenses were built in Canada. They were about 5 feet off the ground. So as this rover drives around gathering images, it's kind of like someone who's 5 feet tall taking images or video and exploring Mars. So the reason that they build 2 of them, it's not that much more expensive to build 2. And by launching 2 of them, you can go to 2 very different regions to try and get a wider idea, more information on what Mars is like. So they went to the Meridian Planum and Gusev Crater. Gusev Crater, they thought, had been a flooded crater or a lake. Now, the 2 rovers lasted very, very long compared to what they were supposed to. They were supposed to last 90 days, 3 months, and they lasted much longer. Now, Spirit survived for 7 years and traveled a distance of about 7 kilometers. Unfortunately, what happened with it, Mars has seasons. It's very cold on Mars. That's one of the things about it. And what they do in the wintertime is they find a spot to shelter the rover, and they kind of put it to sleep. They close everything down, keep a bit of heat so it doesn't freeze too much. And then when they can move again in the spring, they start driving around. The problem with the Spirit was that while it was sitting there, it's very sandy, kind of like a desert, and it sunk into the sand. And when they woke it up, although it was able to operate, the back wheels were spinning and it was stuck. And of course, there's nobody there to move it out. Now, Opportunity only recently stopped working after 15 years. Remember, Mars is on average minus 60. There's windstorms kicking up dust everywhere. There's rocks. You'll see a little bit later on how hard the planet is on equipment and technology. It really beats it up, and that's one of the reasons why we're surprised how long it lasted, because Mars is still a pretty hostile environment. So it traveled about 45 kilometers, and then one day it just stopped transmitting, and they're not totally sure why. But here's a great image taken from another robot in orbit showing you the tracks of Opportunity. It's not a blurry picture, by the way. It is a picture in 3D, so that's why it looks a little bit off, but you can see where it was driving to check out this place called Duck Bay. And again, just to give you another example of the kind of terrain that these rovers have to drive around. And one of the reasons they drive so slowly is to look at the rocks, look at the sand. You don't want to get stuck. You don't want to be buried. And there were times when these rovers have gotten stuck in the sand. They do their best to try and pick the most solid path, but sometimes they do get stuck and there's no one there to push them out. So they've got to be very creative in their ways. They've got 3 wheels on each side for that reason, that they can try and maneuver out of a stuck situation. Now, the rovers did discover that there was or had been flowing water on Mars based on some of the images of the rocks. Now, to you and I that might look at this rock and not really understand what we're looking at, but a geologist can see that these markings on the rock were created over a very long period of time where a liquid, presumably water, flowed and carved these markings on the rock. So once those two rovers had been successful, NASA decided to send another rover to Mars. This one looks a bit familiar. This one's not Perseverance, but its predecessor, Curiosity. This one is the size of a small car. It weighs about 800 kilograms. It's not solar powered. It is powered by a radioactive decay. And there you can see Curiosity has been on the planet for a little over 8 years and traveled 24 kilometers. It is still going strong today. And much like the other rovers, it has certainly sent back information and data to let people know that Mars was once a very different kind of planet with a lot of water that was flowing around on the planet. These little blueberry shapes are created with water flowing over the rocks for a long period of time. So millions of years ago, not only was the planet covered in water, much like Earth, but it was warmer and its atmosphere was much, much thicker. So, of course, one of the questions that they want to answer is, what happened to Mars? Since it was more like Earth, what happened, and could that happen here? Here are just a couple of images, and to show you the different size of the robots over the years, we've got the little Sojourner, we've got the Spirit and Opportunity rover, and then the Curiosity rover. Now, getting to Mars takes a long time. If you know anything about the planets, you know that they are orbiting around the sun. And if you see here, you can see that we have Mercury, Venus, Earth, and Mars. And as we go from the center outwards, the planets take longer and longer. So if you look at Mars and you look at Earth, they are orbiting in different orbits. So you can't just decide. It's not like going to the store. The store is always in the same place. You just go there. There are times when Mars and Earth are extremely far apart. So you have to wait, and this happens about every 2 years, for the planets to line up so that you can then send a spacecraft from Earth. And remember, everything is always moving. So you're much like throwing a football, you're throwing or sending the spacecraft to where the planet will be in the time it's going to take to get there. So it takes about, on average, 7 to 8 months, usually, for the spacecraft to get to Mars. And like I said, it only happens about every 2 years or so. So landing on Mars is not easy as well. And that's maybe why, for some of us older people, we look at it and we are just blown away by the fact that they were able to land on Mars, because as we were growing up, looking at them sending missions to Mars, well, you can see there were lots of attempts that didn't make it. One of the most famous ones, and I remember it well because we had students here watching NASA on TV when they were talking about the Mars Climate Orbiter, and it was going to enter the Martian atmosphere. It was going to orbit around. This is a $125 million satellite. And unfortunately, what happened was we had the room full of students. We thought this would be great. They're going to see this. Of course, it's all animations, but because there's no one there actually videotaping it. But we thought this would be really a great experience to talk about it happening. And instead of going into a very high orbit of 226 kilometers, it was in a very low orbit and crashed. So what eventually was found out was that we talk about units of measure, and I think for our students, we often impress upon them when you're writing an answer down, you write down what unit you're using. So is it meters? Is it seconds? Is it hours? Kilometers? Whatever. In this case of the spacecraft, the Americans tend to use the imperial system, and a lot of other countries use the metric system. There was information sent back and forth, and unfortunately, someone didn't write down the units. Somebody interpreted them to mean imperial, when they were supposed to be metric, and the difference in the information caused the spacecraft to crash. Now, that was 1999, which was a while ago, but even as early as 5 or 6 years ago, this is the Schiaparelli lander. This was a joint mission between Russia and the European Space Agency. It was due to land in 2016. It was doing great, got all the way there, was 1 minute away from landing, and they stopped hearing from it. It was many years later that they found the pieces of what they believed to be the lander having crashed on the planet. So how do you land on Mars? Well, one of the questions that the students were asking was, what do you use to help the landing of the rover? So over the years, there's been a few different ways to land on Mars. Here's one of them. So of course, you're going to launch in a rocket. It's going to take you about 7 months to get there. Now, Mars has an atmosphere. It is very thin compared to Earth, but we take advantage of that. And if you guys, I'll stop this for a second, if the students can just put their hands together and rub very quickly, what you'll feel is heat because of friction. So even though the atmosphere is very thin, when the spacecraft enters the atmosphere, it'll heat up, it'll slow it down, which was what we want it to do. And then they're going to open up a very big parachute. Has to be bigger than normal because the atmosphere is so thin. Now, on the bottom of that spacecraft, there was a heat shield to protect it. And now it's just a heavy weight. So they're going to get rid of it. And then this is how they landed with Spirit, Opportunity, and the Sojourner. Okay. So there it is. The robot is in that triangle. And now they want to protect it. And so they come up with an ingenious way using airbags. So they inflate them all around the robot. Now, remember those rocks I told you to look at earlier? They were all over the surface. These are airbags. Now, they're very, very tough, but they're bags filled with gas. Now, at the right time, they're going to fire more rockets to slow it down and then release it. And it's going to bounce. So think about the robot that is inside. This robot has to survive being dropped and bouncing all over the planet. I certainly don't think cars today would survive this. They might work, but they'd certainly be pretty beat up. So think about all those rocks that we saw earlier. Any one of them could easily puncture any of these balloons, these airbags. They're going to deflate the airbags, then they're going to open up. That's why it's triangular shaped, so they can flip it around however they need. And hopefully the robot is working at this point. This all takes a while to do. And then it's going to turn itself on, unfold, start gathering power with its solar rays, and then hopefully drive away unharmed. So that's the airbag landing technique, and it worked. It worked for those 3 missions, as I said. It is not very accurate. They float down on a parachute, which isn't accurate. There are winds, and they're up to the winds to decide where that parachute is going to go. And then, of course, once they let go and the spacecraft is bouncing around inside those airbags, you really have no control. So it worked, but it wasn't very accurate. And then when Curiosity was sent there, and the same for Perseverance, we're now talking about a much, much bigger rover, 800 kilograms for Curiosity and over 1,000 for Perseverance. So they had to come up with a much different way of landing. And here you can see kind of a breakdown. They are always going to use the atmosphere as much as they can to slow down. And then in the case of Curiosity, they also used a very similar parachute system to the previous missions. So here it is. This is a combination of animation and real footage. So the real footage, there it is right there, came from Perseverance. This was the first time we'd ever actually had video of a landing on Mars. So if it looks like this, it's real. The other stuff is the animation. So here's the parachute. opening up. We're now looking up. Now the spacecraft, in Curiosity's case, they just had a parachute and it floated down wherever. In the case of Perseverance, they had a system to decide when exactly to open that parachute up. So this is what it would look like. This is an animation of what it would look like if you were standing on Mars observing this spacecraft floating down. So this is actual footage of the heat shield being separated. It's now just a dead weight. And what you're seeing, the pink area, that is the surface of Mars.
Has slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So Perseverance is now floating down. One of the big differences between Curiosity and Perseverance is the technology was much better on Perseverance. And
resolution 3.3 meters per second, altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface.
So it is now actively looking for at the surface and comparing it to maps. And unlike Curiosity, which just landed wherever, it is now deciding where it wants to land.
It is about 90 meters per second at an altitude of 4.2 kilometers.
So that's the actual surface of Mars.
Yes, valid.
There's confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Driving. TBA is nominal.
We have timing of the landing engine.
So what they're just saying is this: the computer on Perseverance has decided it now knows exactly where it wants to land. It's made that decision, and now it's armed its rockets, because what they're going to do is they're going to have a rocket bring the rover down to the surface. There's a crater on Mars.
Back shell set.
Current velocity is
So we just separated from the parachute, which was held in place by the back shield.
83 meters per second at about 2.6 kilometers from the surface of Mars.
So this is an animation of what just happened. There is this robot, there it is, having been released from the parachute, and it's now going to fly down and land exactly where it wants, in the case of Perseverance, on
We're
Mars.
currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here on safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
So this is real footage. Now,
We have
watch
started our
this.
constant velocity accordion, which means
you see all that? That is the dirt on Mars that being kicked up by the rocket engines. And the reason that they're going to do the next maneuver, they don't want that dirt, perhaps small rocks, to be kicked back up, because remember, on the bottom of this rocket, underneath, and you'll see in the animation, is the rover. So looking on the left,
conducting the sky crane,
you're now seeing
about to conduct the sky crane maneuver.
real footage of looking up on the top and looking down at the rover. It's called the sky crane. This is the animation. It's being lowered down onto the surface so that it protects that rover, and the rocket engines can't kick up too much. Still kicking up a lot of dirt, but not. And there is the robot having released the lander once it touches down, flying away.
On the surface of Mars, ready to begin seeking the sands of past life.
So this is the animation of what had just occurred. So that is how they landed both Curiosity and Perseverance on Mars. But of course, the question is, where do you land? And you can see here where some of those landers were. We talked about Viking 1 and 2, Opportunity and Spirit. So the choice to do this took a long time. It took about 5 years. There were 60 possible locations. People, scientists from around the world, were giving them information as to decide. And after 5 years, they finally narrowed it down to a place called Jezero Crater. You can see where Perseverance is. Now, it is 45 kilometers wide and located on the western edge of a flat plain called the Decidius Planeta, which lies just north of the Martian equator. And the site is about 3,700 kilometers away from Curiosity's landing at a place called Gale Crater. So this is Jezero Crater, and you might wonder, why did they land there? Well, they believed that this area was it's a crater, meaning it's a kind of a basin or a indentation in the surface, and they believed it was flooded with water. They believed that 3.5 billion years ago, right through here, this water, like a river, flowed. And of course, it spilled into this crater area. And when it did, is the water moved. Water is where we think there would be life. Life and water kind of go together. And so if there was water, millions, if not billions of years ago, and that water was flowing, if there was life there, it might have gotten trapped in the muds and the clays as it rolled along and spilled out into what would be Jezero Lake. And so there is possibilities of past microbial life being trapped in those dirts. And that's what that is. That's called the delta. And that is where the muds were spilled out into Jezero Lake. And the green stuff right there, well, that is a mineral. These images are real, but they have been, the colors have been added based on the information from a spectrometer, and to show the scientists very easily where these minerals and things are. They believe that green area was a shoreline, and there was a carbonate material there, and they think that that's possibly where some of that life could have been trapped. So you think about it, they landed this rover in an area 7 by 6 kilometers, having traveled from Earth 200 million kilometers away. That is truly spectacular. So there's just a little animation showing what they believe Jezero Lake looked like. And then, of course, it dried up, and what is left is the muds, which is in the delta, which is where they're going to explore. Now, although they look the same, there are some differences. One of the students asked, are there different design ideas when they were trying to think up Perseverance? And the answer is yes and no. They had done other designs, as you've seen, with Opportunity and Spirit, but Curiosity was working really well. And the time and the effort it takes to create a brand new rover, it's staggering. It takes many, 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 many years. So you had the basis, which is the Curiosity rover. That design, we know, for the last 8 years has been working really, really well. Why don't we just take that and make some modifications and adapt it? So they do look very similar, although there are a few differences. So Curiosity has been on Mars for 8 years. Here's some video from it. And it's done a lot of exploring and given us a lot of information. As we said, we know now that Mars's atmosphere used to be a lot thicker. Therefore, the planet was a lot warmer. It had a lot of water. That water, much like the Earth, was flowing and moving around. So that Mars used to be a lot different. Now, the other thing that Curiosity has discovered was ancient organic materials that Mars once had the right chemistry to support life. And so that's why we now have Perseverance looking for possible past life. The key ingredients for life are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So they haven't found life, but they have found the right chemistry. The other thing that was kind of a good thing to know, but a bad thing to have, is the radiation on Mars. One of the things we're thinking of is human exploration, and we wanted to get a really accurate measurement of the radiation on Mars, because then we would know about the kind of structures we have to build. So that was some of the information that Curiosity has brought back over the 8 years. And one of the differences, as I said earlier, was in the landing. And the landing of Curiosity, it had the parachute. It just kind of landed with the sky crane wherever. With Perseverance, there was systems on board that were going to tell it exactly when was the best time to release that parachute. Because once the parachute's released, you don't have a lot of control. You are up to the whim of the winds, so to speak. And so you want to make sure that you can be as accurate as you can be. So they released that parachute at the right time. This was a new landing, entry, descent, and landing system. And in a way, it was a test possibly for future missions with people as well. And of course, that sky crane, they had a system where they could actually read the ground and study it, compare it to maps, and they knew exactly where they wanted to land. So again, they used the same sky crane technique because they didn't want to kick up the dirt from the rocket jets. One of the big differences is in this robotic arm, which is a more advanced arm with a 65-pound, 30-kilogram, they call it a turret on the end. That's where you see the word Sherlock. Sherlock and Watson are two different kinds of cameras that are on the end of that arm. It's a 2-meter long arm, and it's also got a drill on the end. So they can actually, as you'll see in a few minutes, drill down. By the way, Sherlock and Opportunity being cameras are also used for all those selfies that we see of the spacecraft. So these are some of the tools one of the students was asking. They've also got lasers on there so they can zap the rock and then see what the composition of the rock is. And that's where the super camera comes into play. So there's that robotic arm. And there you can see those are the cameras that are mounted, both Sherlock and Watson, and the cameras will be used along with the laser to research for organics and minerals that are been altered by the watery environment in the past. Now, Sherlock's camera is a black and white camera to assist Watson, which is a color camera for taking close-up images of those rock grains once it's been zapped, looking for textures perhaps made by water or past life. And as I said, one of the big things that they're going to do that's very, very different and why they landed at Jezero Crater is they want to drill down and actually collect samples of the soil and rock. So this is a video, an animation of what they're going to do and then some testing back on Earth. So this is what it's going to look like when they start to drill down. This is the testing. The tubes that they're going to collect, there's an actual image of grabbing the tube from underneath the robot and then putting it in place and drilling down into the rock. So they have these tubes. There's the white thing right there. Those are the storage tubes in which they will collect these samples. And there they are. So they have 43 of these sample tubes, and they're going to drill, and then they're going to leave them on the surface of Mars in different areas for a future mission to come and collect those samples and bring them back. And to design these sample tubes to be as absolutely clean as possible was very, very difficult. They didn't want to go through all of this effort, get the tubes back, get the evidence, and go, wow, we found evidence of life, only to realize that was something that had been sent from Earth because they hadn't cleaned the tubes properly. Now, the bad news is that the sample return isn't designed yet. They're still talking about it. So probably the earliest time, 2028 to 2030. So 10 years from now, those samples will be sitting there. Possibly the Europeans are talking about developing a little robot with a little rocket that'll go along and pick up those samples and then shoot them back to Earth. And we only hope that drilling into the surface for Perseverance is a lot better than it is for the InSight lander, which was landed on Mars by NASA a few years ago, that spent 2 years trying to drill down and found that they just couldn't do it. The surface was too tough with the drill that they had. So hopefully Perseverance does a lot better. There are 23 cameras on Perseverance, and unlike Curiosity that had 2 megapixel black and white photos, the cameras on Perseverance will capture 20 megapixel full color images. There's also microphones to hear the sound of Mars as well. And there's the super camera. And there's a Canadian connection as well, and that is that the data from that supercam has to be transmitted through the spacecraft to different pieces of technology to be analyzed, and that's done through fiber optics, and those cables were built in Kitchener, Ontario, in a Fiber Tech Optica plant in Kitchener, Ontario. Now, I said earlier about how rough Mars is on technology. And the metal wheels of Curiosity, you can see here, have gotten beaten up over the years, and they're made of titanium. That's a pretty tough metal. So having learned this, they decided that they were going to redesign the wheels on Perseverance. The other reason was there was a period of time when Curiosity did get stuck in the sand, and they were able to get it out, but that doesn't always happen. So they wanted to try and come up with a better design, and the wheels on Perseverance are slightly larger in diameter and slightly narrower as well. Plus, you can see the tread pattern. The other one on the Curiosity was called a chevron pattern. This is more of a kind of a bit of a wave pattern, and there's more of these little treads as well. So hopefully that'll mean that it can not get stuck and move a little bit easier. And as far as moving on the planet, how fast does it go? It really doesn't go fast at all. Now, Perseverance won't be able to go faster, but it will be able to go farther. I'll try and explain. So they can both go about the same speed, which isn't really fast at all, 0.14 kilometers per hour. Just to put that in perspective, humans, if you're just going for a nice walk, not a gentle walk, but a decent walk, we walk at about 5 kilometers per hour. If we're just trying to get to school, hopefully, or trying to get somewhere, then we're walking at 5 kilometers per hour. So many times faster. That gives you an idea of just how slow these rovers can be. And in the case of Curiosity, there's another issue. Here's an example. It's from Spirit, but same concept. You can see where it says Sol 1. That is where it landed. And then it has to travel, and that's that yellow line. It's only going about 50 meters per day. And here's what's happening. You look at the path, it didn't go in a straight path, and it stopped on Sol 65 and turned around and took a picture, which means it traveled in 2 months on Mars only 328 meters. And here's the reason why. That rover has to then it'll look around wherever it is, take a bunch of images, and send those up to another robot that is in orbit around Mars. They can only do this every once in a while. It's not always possible. So they have to wait for that. And then that data is transferred up, and then that data is sent back to Earth. And that portion alone can take 5 to 20 minutes. Now, people on Earth get all the images and data, and they make a decision after meeting. They look at everything and say, okay, we think the rover should go in a certain direction and so many meters. And then everything is reversed. They send that signal back to the spacecraft in orbit, which then transmits it down to the rover. The rover then drives that distance, which might only be 3 or 10 or 20 meters, and then it stops and reevaluates and does this whole process all over again. Now, one of the students asked, what would happen if you lost connection with the rover? And yeah, that can certainly happen, and that's something they've thought of. So the rover knows when it should be talking with Earth, and if for some reason people on Earth don't hear from it, the rover's like, okay, I haven't heard from Earth. It'll automatically, with the programming on board, say, okay, let's make sure we're okay. It'll go into a safe mode. It'll actually try and make sure that it check itself out. It might try and restart itself or portions of itself to make sure there's no problems, but it will certainly go into a safe mode. And then, of course, people on Earth will also continue to be trying to contact it in various ways, perhaps using other satellites or other pieces of equipment on Earth to transmit the information, and hopefully they can reacquire the signal. So it has happened, and sometimes it's just a little glitch, and they have, just like in your computer freezes, you do a restart, and it's all good. So it does happen, and they will try as best as they can to reestablish contact. In the case of Opportunity, that's what happened. They were talking to it. All of a sudden, they went to talk to it one day. It wasn't answering. They spent a year trying to contact it before they finally said, okay, we are done. And that deep space network is a series of antennas on Earth that allows them to track all of these and communicate with all of these rovers and spacecraft out in space. So it's using the difference. What's going to be with Perseverance is instead of that really slow process, it's got all these cameras and it's got the Mars Reconnaissance Orbiter, which is also giving them information. It's scanning the surface, and it's going to take all this information. And then when NASA says, look, we want you to go there, and it'll give them a coordinate, what will happen is instead of the robot having to do all this sending information and people on Earth making decisions, the robot, the artificial intelligence on Perseverance, will, along with the data from the Mars Reconnaissance Orbiter, decide what is the best route to get there. So although it can't physically go faster because of you're not having these delays, it'll actually end up with the artificial intelligence going 3 times faster on the surface. Now, one of the really cool pieces of technology that is on Perseverance that wasn't on Curiosity is another test instrument called MOXIE. We are thinking of sending people to Mars in the future. Mars' atmosphere is carbon dioxide. So we need to find a way to make some changes to that. And MOXIE is the test vehicle where what it's going to do is take some of that CO2 and find a way to convert it into oxygen. Now, we would need this if humans want to be there to breathe, but also rockets need usually oxygen to work. And so they need what's called an oxidizer. And so being able to do this would certainly help us in using rockets to come back or send things back from Mars. And if this works, perhaps a larger version will go and be set up to create some sort of habitat where it would slowly be filled with oxygen in preparation for humans on Mars. Now, let's not forget that there's that little Ingenuity helicopter, which is again a test vehicle to be flown around on Mars. So it's very, very small. It's only about 1.8 kilometers, 1.8 kilograms, sorry. And what they're going to do is they're going to test it out. The flights will always be very short, only a few minutes long. It's got a camera on the bottom. But if this works, and with that thin environment, you got to really rotate that rotor really, really quickly. We don't know if that'll work. But if it does, then they can use this drone to fly ahead of the rover, give it the information, much like the Mars Reconnaissance Orbiter, but because it's so close, fine detail, and that'll help speed it up as well. So here's what they're going to do is it's underneath the rover. They're going to drop it, and then they're going to back away, and then filming it from Perseverance or Percy. It's got a solar cell on top to power the battery underneath, and underneath in that little box is also a camera. So it can then fly around and gather. You can see some of the cameras on that masthead there. And as it flies around, it can gather images and send them back to Perseverance. Again, helping speed up and decide on the safest route across the Martian surface. So they're saying now that they'll do the first flight sometime in April. So keep an eye on that. They haven't given us a date yet. Some of the most recent activities on Mars were, it's been there about a month. It hasn't really moved very much because they want to make sure that everything's going to work perfectly before they start driving around. So they've got some images. These are some of the images from where it landed. And they're testing out that turret and the robotic arm. And of course, they're testing the wheels. They want to make sure that those wheels will all work as well. So they've got a little bit more testing before they go. They've taken some images And just to give an idea, this is a part of the delta we talked about. It's 2.3 kilometers west of Perseverance and is about 10 meters high and about 200 meters across. But you can see some of the rocks. I mean, they're going to have to pick their way through that to try and start their exploration. I love this one, though, and we talked about the fact that there are microphones on Perseverance, so listen to the sound of Mars. So that's the sound of the wheels being tested and moved around on Mars. They don't know what the scratching noise is. They're trying to figure that out. So just to wrap things up, I want to show you a couple of cool features that are on the Perseverance rover. The scientists, they spend years designing this, so they come up with some kind of interesting features, if you will, on the rovers. This is a sundial, which is used to tell time, but they've also covered it in swatches of different material to see how they react to the Martian environment. And then they've got symbols that all have different meanings. Now, the symbol of the man and the woman is similar to the one that was on the Pioneer plaques of those and the gold records of the Voyager 1 and 2 spacecraft where they're gone off into space. And if you look carefully around one edge, there is a couple of different sayings that have been etched in. One of the questions is, are we alone? And the joy of discovery is another one, and it's been done in multiple languages. If anyone's ever heard of geocaching, that is something where you look for, using GPS coordinates, you look for different things that have been hidden around, usually in forested areas, but urban areas too. This is a geocache on Mars. And one of the cool things is that, again, they have different materials that are exposing to the Martian environment. And you might notice in the corner, it says 221B Baker Street. And if you have read any or watched anything about Sherlock Holmes, that was the address of Sherlock Holmes. That is a piece of space suit material, helmet visor material, that they've etched that in. And of course, the names of the cameras on the turret are Watson and Sherlock. So they've kind of kept up with that theme. This is a little piece of Martian meteorite. So it's made a round trip. It was found on Earth. It was brought up. In this case, you're looking at it on the space station, and then they sent it back, or at least a piece of it is on the Mars rover as well. And then they've got a list of names. One point before the mission, you could sign up and have your name put on. So somewhere etched in very fine writing is about 10 million names, along with people who also participated in the building of it, but also just people who wanted to have their name on Mars, which is kind of cool. And you've probably seen all these kinds of things on, people put them on their vans and their cars to show off their family. Well, Perseverance is no exception. So there you can see, it's kind of hard. I'll do a close-up of it. And there's the Perseverance family, starting with the Sojourner, Spirit, Opportunity, Curiosity. And then they also decided to add a little plaque for the, I guess, to honor the people with regards to the COVID-19 pandemic, and to just a way to salute all the healthcare workers from around the world. So the mission is planned, they call it a 2-year prime mission. There's the Delta, there's the path I hope to take. And someone asked, when will Perseverance be coming back to Earth? How will they bring Perseverance back? And like the other rovers, the answer is they won't, and it's not coming back. But the other part that Perseverance is doing there is a lot of the technologies we talked about, like Moxie, like the landing systems, those are all being tested for the idea that if they work, they will then be used later on when we decide to send people there. So it's also checking radiation levels as well, checking the atmosphere, all of these things we need to know if we want to send people there. Now, they're saying that there is the chance we'll have people there in 2030. I think it'll probably take a little bit longer. Someone asked, can people live on Mars? Because they have found water there. But as we found out, because of Curiosity, the level of radiation is much, much higher. And therefore, if we do go there, we'll have to live either in structures that are well protected or find a way to get underneath the surface to protect ourselves. So yeah, the water is great because that will certainly help with surviving on Mars, but there's a lot of other aspects to it as well. And then lastly, a couple of things I want to show you. A student asked, are there sunsets and sunrises on Mars? And the answer is yes, there are. They look different than on Earth. This is one, it's blue in color. And that is because the light has a longer distance to travel within the atmosphere. And so it scatters more. And the color that is left is the color that we, if we were standing there, would see. On Earth, we tend to have more red colors in our when we see our atmosphere in the sunset, but on Mars they would be blue. And I'll leave you this one little challenge, if you will. Again, they're always putting little hidden, I call them Easter eggs, all over the spacecraft, and one of them is in the parachute. And so they had to have a design for other reasons so they could measure how much it was moving with the camera, but they decided, let's put a message in there. So I don't want you to cheat. See if you can figure it out for yourself. Don't look up the answer. But is in binary code. There is a message written in the parachute that you see here. So see if you can figure that one out. I'll give you one clue, and that is that the message was made famous by President Theodore Roosevelt. So I want to thank you very much for watching today and listening. I'm hoping you enjoyed our exploration of Percy. As the mission goes on and there's more information about it, I'll probably come up with another presentation to talk about what it has discovered and how it's doing. If you have any questions at all about Percy or anything to do with space, human exploration, or the planets, please feel free to email me your questions, stephen.lang@tdsb.on.ca. So thank you very much. I appreciate that you joined me today, and keep looking up at the stars.